1.3 is about rates, ratios, and proportions. And our essential question is, how do we use ratios and proportions? A ratio is just a comparison of any two things, or a comparison of two quantities using division. A ratio is something that you hear a lot of times when you're talking about sports. A batting average is a ratio in baseball. Comparing the number of boys, the number of girls in a classroom, that is a ratio. You're comparing any two things using division. When we have two ratios that are set equal to each other, it's called a proportion. It's really still just an equation that we can solve and manipulate in a similar way as 1.1, but this special kind of equality is called a proportion. So we're going to talk about how to solve these proportions in this section, and then we're going to talk about how proportions are something that are actually used in real life on a regular basis, and maybe even something that you have used without thinking about it. So for problem number 1, we have 3 over x, that's one ratio, equals 5 over 4. That's our second ratio. The thing that makes these problems confusing for a lot of people, or maybe just scary looking, is the fact that we have fractions. We have one fraction equal to another fraction. And just like in 1.1, there's a really simple way for us to get rid of the fractions, to get rid of the scary part. And that is to multiply both sides of the equation by that common denominator, or to multiply, to use the multiplication property of equality, by something that's going to make it so that we don't have fractions. So what we're going to be thinking to ourselves is, what is the common denominator? And can we multiply both sides of the equation by that common denominator to eliminate fractions? So when I look at number 1, I'm asking myself, what is the common denominator? I have x in one denominator, I have 4 in another denominator. So I know that the common denominator is, in this case, just going to be both of those things, 4 and x. So if I multiply both sides of the equation by 4x, I can actually get rid of my fractions. And I'm going to show you that step here. So in blue, I just have the original problem. And if I multiply both sides by 4x, remember when we multiply with fractions, we're multiplying across the top and across the bottom and dividing. Or you can simplify anything that's in the numerator and the denominator. So on the left-hand side, I have an x in the numerator and I have an x in the denominator. So I can simplify those and just multiply 4 times 3 to get 12. On the right-hand side, I have a 4 in the numerator and a 4 in the denominator. So I can divide those to be 1. So I'm left with 5 times x, which is 5x. Now we're just back to a 1.1 problem, a solving equation problem. 5 and x are multiplying. To undo that multiplication, I'm going to divide both sides by 5, which is going to give me 12 divided by 5. So remember, we're multiplying in order to eliminate all of the fractions, and once that step is accomplished, we're just back to a simple solving equations problem. Number 2, 4 over 21 equals negative 2 over 15a. So I'm trying to think of a number that 21 and 15 both multiply into. And for a problem like this with this size numbers, I think it's okay if you need to use a calculator. I'm going to tell you that their common denominator is 105. And since there's an a in one denominator, the common denominator is going to be 105a. So what that means is I want to multiply both sides by 105a. So, and I'm going to write 105a over 1 since I have fractions. That's going to make things a little bit easier. 105a times 4 over 21 equals negative 2 over 15a times 105a. And now we're going to simplify. So 105 evenly divides by 21. That's a part of the reason that's our common denominator. 105 divided by 21 is 5. So now I have 5 times a times 4. So if I multiply 5 times a times 4, I'm going to get 20a. Ooh, that doesn't look like an a. Let's try again. Equals 105 divided by 15 is 7. And these a's are going to divide to be 1. So negative 2 times 7, that's going to give us negative 14. To solve for a, we're going to divide both sides by 20, and then always, always, always simplify your fraction. 14 and 20 are both even, so I can divide them both by 2. 14 divided by 2 is 7. 20 divided by 2 is 10. And I'm going to put set notation around that. So A equals negative 7 over 10. So number 3 actually looks a lot like a problem from Unit 1. You could think about this as 8 over 1, and then I have a ratio equals to a ratio, and I could find that common denominator, and that common denominator is n, and you could work through it in the exact same way. You could also think about this just as a regular solving problem. I don't want n to be in the denominator, so I'm going to multiply both sides by n. So either way, your very first step is going to be to multiply on both sides by n. That's going to give us 3, because if I have n over here, n divided by n is 1. 3 is going to equal 8 times n. And now to isolate n, I'm going to divide both sides by 8. So n equals 3 over 8. Number 4 looks a little bit more intimidating because there's different stuff happening in the numerator. But think about what's happening. I have a proportion. What do I do when I'm solving proportions? I multiply by the common denominator. In this case, the common denominator is 30. 5 and 6 both go into 30. So I'm going to multiply both sides by 30. And I'm going to show this work. 30 over 1 times 2n minus 3 over 5, and then I can simplify here. 30 divided by 5 is 6. So I'm going to have 6 times 2n minus 3 equals, over here, 30 divided by 6 is 5. 5 times n plus 2. Now I can distribute 12n minus 18 equals 5n plus 10. I'm going to clean this up so that there's room to finish solving. I'm going to subtract 5n on both sides. So I'm going to subtract 5n so that I can get rid of this 5n. 12n minus 5n is 7n. So 7n minus 18 equals 10. I'm going to add 18. So 7n is equal to 28, which means that n is equal to 4. Remember, with problems like this, you can always plug in your answer and go back and make sure that it works. Similarly, in Unit 1, that's the beauty of solving equations, is you can actually work backwards and make sure that your answer works. The very last thing we're going to talk about today are applications. So we just looked at how to solve, the math behind how to solve, but let's talk about how to actually create a ratio and set up a proportion to solve a problem. So some examples of where proportions come into place in recipes all the time. If you're taking a recipe and halving it or quadrupling it, you're actually using ratios to figure out how much of a product you should put in, or an ingredient to replace another ingredient. Businesses use ratios and proportions to predict, and they use it for ordering. If 100 people ordered this yesterday, then 100 people might order it today, or we might use that to predict how many people will order it over an extended period of time. So you might use these on a regular basis without even knowing it, and that is something that is kind of cool to see how the math plays out in the real world. So we're just going to look at 2 word problems, going to analyze them. We're going to make sure that we define our variable, which is really important, and work through these 2. Number 5, in a certain class, there are 15 boys and 6 girls. Before I even keep reading, I have already been given a ratio. I have been given the ratio 15 boys to 6 girls. And I could have written that as 6 girls to 15 boys, but I'm going to write it just in the order that it's given to me in the problem. So sentence 1, we've done everything that we need to with that sentence. Sentence 2, find the proportion of boys. So we are looking for the number of boys. So I'm actually going to define my variable. You always need to do this. I'm going to let x equal the number of boys. Find the number of boys. Since boys are in the top of the fraction on the left, boys are going to be in the top of the fraction on the right. Find the number of boys there would be if there were 28 girls. So that's really all it takes to set up the proportion. Now you can solve this proportion. Before I find a common denominator, I actually notice right now, and if you don't notice this, that's totally fine. You'll find a different common denominator and still work through to get the same answer. But I actually noticed that both of these numbers are divisible by 3, and I like to work with smaller numbers. If I divided 15 by 3, I would get 5. If I divided 6 by 3, I would get 2. And oh man, I would much rather work with 5 over 2 than 15 over 6. So what I'm really looking at is 5 over 2 equals x over 28. My common denominator is going to be 28 because 28 is even and 2 is also even. So I'm going to multiply everything by 28. On the left-hand side, 28 divided by 2 is 14, and 14 times 5 is 70. So I'm going to do that up here. 28 times 5 divided by 2 equals 14 times 5, which is 70. So that's what the left hand of the equation is going to be equal to. When I multiply 28 on the right-hand side, those 28s divide out, and all that's left is x. Now, the question didn't ask you what is the value of x. In fact, there isn't an x in the original question. It asks you to find the number of boys that there would be if there were 28 girls. So the answer, and I'm going to try and make a box up here so you can see this. The answer to this question is 70 boys. And if I needed to write that answer in a complete sentence, I would say when there are 28 girls, there would be 70 boys. That would probably be a better way. I definitely don't have enough room to do that. If we're not asking you for a complete sentence, then it would be fine for you to just write 70 boys. So it does say in a complete sentence. So I would expect to see there would be 70 boys when there are 28 girls. All right, last question. John ate 4 hot dogs in 6 minutes. Again, right away, first sentence, I'm seeing a proportion. 4 hot dogs, 6 minutes. And actually, even before I keep going, I notice that that simplifies. If I divide 4 by 2, I get 2. If I divide 6 by 2, I get 3. So I'm just going to draw a little arrow. This becomes 2/3. At this rate, how many will he eat? What are we talking about eating? We're talking about hot dogs. So that's going to define our variable. So x is going to equal the number of hot dogs. How many hot dogs were in the top? So x is going to be in the top. Will he eat in 12 minutes? So here we are again with a proportion. I'm going to identify the common denominator is 12. So I'm going to multiply everything by 12. If I multiply by 12 over here, 12 divided by 3 is 4. 4 times 2 is going to give me 8. Over here, 12 divided by 12 is going to be 1, so I'm left with x, which means he would eat 8 hot dogs. So he, or John, would eat 8 hot dogs in 12 minutes. So that's rates, ratios, and proportions. Thanks for listening.